Hello, students. This is the introduction to exercise 5, basics of designing and calculating swells. So for this exercise, you will be given a base map in CAD with 3 swells in plan view. And each swell, you will have a set of variables that's provided for you, and you are to calculate the missing ones. Okay, so be sure to refer to the information on both of the base map as well as the canvas description here, especially the 3 box here, to see what sets of variables are given to you. And essentially, this part of the exercise is very similar to the examples A, B, C, D provided to you in the latter part of the lecture 5, swell basics. Okay, now let's go through the swells one by one. Just to give you a few pointers of where to start with the basic steps. You'll hear me referring to the examples A through B a lot. So be sure that you watch those videos first and then come to the exercise, okay? So for instance, I would say swell number 1 is very similar to examples A and C in terms of the provided variables and in terms of the process of calculating the swells. All right, let's go back to the base plan first. I have a few things that I want to explain here. So these are the swells in plan view. The center line here. Those are the 3 center lines. Okay, so if you see a number by the side of the center line, those are centerline slopes. If you see a slope that is across the swell, that's the side slope. Okay, if we scroll down and we see, okay, here is the edge of the swell, 40 feet typical. What does that mean? It just means the width of the swells. All of the 3 are 40 feet, the same. Okay, you could also measure them in CAD. The next thing, if we scroll down, you will see distance. What does distance mean? Distance means the horizontal distance between HPS and LBS. Basically, it's the length of the swell, this distance. Okay, again, those are extra information that's provided to you, but you can, in fact, measure them in CAD. All right, so the spot elevations given here, given that I'm using a base map from previous years, the numbers that you see might be different. We tend to swap numbers from year to years, but you may get the same numbers as this one. So we'll wait and see, but do not be confused if the numbers that you see are different. The process that you go through is essentially the same. Okay? So the last thing about this base map is that we do not provide a title block for you here. The title block is for you to create on your own. And our TAs have provided you with the title block that's 11 by 17. And here is your chance to create your own in letter size. Okay? Try to practice as best as you can to create your own title block for this exercise. So let's go back to the specific guidelines for each of the swell configurations. So the first one, you're given HPS, you're given a centerline slope, and no, there's no LPS here. So that means the elevation to LPS is for you to calculate. So with that, how do you calculate the LPS? Essentially, that's by calculating V, right? It's elevation related. So you know the horizontal distance, which is that, and you know the slope. You know the higher elevation. Basically, you use the V equals to G multiplied by H, right? To find the vertical change, and then subtract that from HPS. But the next step is a little more complicated than what we provided in the examples in lecture of A and C. because now what we have is not whole numbers along the center line anymore, right? We have an HPS 73.35. If the first steps are using the slopes to turn on my commenting on this document as well. So if the steps is to locate and draft and label whole number contours is a little more complicated than the example, right? Because now what we need to do is to find where the 73 contour is along the center line. What about 72, right? 72, 71. And once you calculate the LPS, you would know how the lowest elevation is. So you will know which whole number contours that you need to plot along the center line, right? So in order to find the contour spacing here, you only need to know the centerline slope. But in order to find out where this next contour of 73 is, you would need to use vertical change equals to 0.35 and the centerline slope to get to the horizontal distance between 73.35 and your 73 whole number contour, right? And following that, the next step will be just to use your swell depth here of 12 inches, 1 foot, to find out if, now supposing this is where 73 is, then your 74 on the edge would be right there at that location. And lastly, you'll connect the dots. Okay? So for the second swell, you're given HPS, you're given side slope and LPS. So essentially the first step will be using HPS and LPS and the horizontal distance to find out what slope it is along the center line, right? And then you go locating the full number contours. Again, where's 54, where's 53, all the way to 49. Right? And then you use the side slope here to calculate what the elevation here is, corresponding to the center line. Next one, you'll be calculating and plotting, connecting the dots, right? And because you have already calculated the centerline slope, now the last step here is basically to label them. Any essential slopes and spot elevations needs to be labeled. The last one, the swell number 3, is the most complicated out of the 3. But if you look closely to the base map, essentially this means you have 2 centerline slopes, right? So the slope of the centerline for this one is changing. It's not a uniformly sloped swell anymore. But that doesn't make it really difficult to solve because you can essentially treat this one as 2 swells. So using the 3.10 centerline slope here, you'll be able to calculate that spot. And using this middle spot and 5.50% centerline slope for the second segment, you'll be able to calculate LPS, right? And then you use the same procedure to locate the whole number of contours, among these different points. Essentially, you are calculating 2 swells. Very similar to swell number 1, very similar to this one, and very similar to examples A and C in our lectures. Okay? Once you calculated out the center line, you know the depth of the swell is 1.5 foot. And then you calculate the edge and connecting the dots. I need to apologize for the piano in the background if you hear it. I'm sorry, but I'll be quick. Actually, that is all. So those are the tips that I can think of to get you started. Please bring additional questions to the class. Thank you all for listening. Thank you for your patience and understanding. We'll see you in class. Thank you.